Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh and in this video we'll continue learning about pandas and GroupBy. In previous video we looked at how GroupBy works and we also looked at different scenarios where we can use either index or column names or combinations of that to get a GroupBy performed. In this video, we'll look at how we can use aggregate along with GroupBy. And in doing so, we'll also look at how we can avoid conversion of a column to index when we perform a GroupBy. We'll also look at how we can use multiple functions at once. For example, mean, standard deviation, sum, all at once can be applied to a particular column or more than one column using aggregate. And then we'll look at a couple of ways in which we can rename the new columns that are created after we do aggregate on a GroupBy object. So let's get into Jupyter Notebook and start coding. Here I've already created a new notebook and imported two libraries, NumPy and Pandas. And for data, we have this DataFrame df, which has column fruits and grade. We are going to use those two for grouping, and then we have two numeric columns, quantity and price. So let's get started and do the first GroupBy. And in this particular GroupBy, we are going to use the simple GroupBy statement. So we'll first create a variable g in which we'll store the GroupBy object. So df.groupby, and this will be grouping on fruits. So that's the object we are creating, and if we want to take a look at what the groups are, we have the groups banana, mango and orange, and in each of those we have these values, indices that are listed. So those rows are within those groups. Now if we want to get the sum of the columns in the data frame, we can just use g.sum, and thus we get the sum for the quantity and price for each of the groups. So for example, for mango, if we look here, we have mango, we have 11 plus 2, that's 13 for quantity, and that's what we get. And then for price, we have 10 plus 12, so that's 22, and that's what we get here. Now we can get the same type of operation performed using aggregate. So to do that, let's see aggregate, and to do that we would type g, which is the GroupBy object which we have already created, and on this we can write aggregate, and within parentheses we'll type np.sum, and this will give us the same output that we had earlier. There is a short form method of typing the aggregate, which is .agg. So g.agg np.sum, and we get the aggregated amount, which is the sum in this case for each of those groups in the data frame. Now what we have done so far is we have used only one column for grouping, which was fruits. How about we use more than one column? So in the data frame that we have, there are two columns, fruits and grade. So let's try grouping using both of these columns. So we're going to go ahead and create a new grouped object g, df.groupby, and here we are going to use the fruits column, and we are also going to use the grade column. Now in this grouped object, if we are going to go ahead and get the sum, the method is the same. So g.agg, and here if you specify np.sum, now we have the aggregated sum, which is based off of two columns, fruits and grade. Now you've probably noticed that whenever we are performing a GroupBy or aggregate after on a grouped object, we are automatically converting the columns into indices. so it's becoming a multi-index data frame that we get in the output. So is there a way to avoid that, and could we keep the columns as they are after a group by or aggregate operation is performed on the data set? And the answer is yes. So let's try to do that now. I'm going to create a couple of cells here, and we'll use the same data frame. So but we're going to create a new object. So g is equal to df.GroupBy, and again we'll use fruits, and the second one is grades, and after this we need to specify as underscore index is equal to false. Now when we use this grouped object and apply agg np.sum, we get an output where the column fruits and grade stay as columns and they are not converted into indices. So that was how you can do that by using the by setting as index is equal to false. By default it is set to true. Next, there is another way which I've used quite often when resetting the indices, is using reset index. So reset underscore index. So to use that, we would type df.GroupBy and say fruits and grade. Now here we are not going to specify anything, but now if you get the sum of all the columns in the data frame and then specify dot reset underscore index, this will work the same way, and you'll get the output where the columns on which we grouped, which is fruits and grades, stay as columns and they are not converted. They are converted back to columns. So if I remove this part, run this, now as you can see they are indices, but when you apply reset index, you can convert them back into columns. Now there are a couple more things you can do with GroupBy object. So let's go ahead and create another GroupBy object, df.GroupBy, and again I'm going to use two columns, fruits and grade. Now if we want to get the size of, that is the total number of, let's say, rows in each of those groups, what we would need to type is g.size and g.size, and here now you can see that we get the count. So it seems that only orange A has 2 counts. Let's go and look in the data frame. So orange A has 2 counts, right? So these 2 groups have 2, all others are only once, occur only once in the data frame. In addition to size, you can also use multiple statistical functions, and one of them is describe. So if you were to type g.describe, what this gives us is for each of the groups we get a whole array of statistical measures for each of the numeric columns. So for a quantity and price, we get count, mean, standard deviation, and then you get minimum, maximum, and then the quartiles as well. So that's really awesome. In just 2 words we get so much information for a data frame, and that is grouped by the groups that we have here in fruits and grade columns. Next, let's look at how, if there is a way we can apply multiple functions to the same data frame or a series in one go. To do this, so let's create another heading, multiple functions at once. So to do that, let's go ahead and use the series price from the data frame df. So this is our data frame, and let's go ahead and use the price. So I'm going to go ahead and create a new object. So df.GroupBy, and here let's use fruits again and grade. Now for this, instead of using the entire data frame, I'm just going to use the price column. So to do that, you would simply type G open square bracket in within quotes price, and then you want to type .agg. So what this is telling Python is that we are going to do the aggregate only on the column price, and the grouping is of course done by these two columns, fruits and grade. So AGG, and now within the parentheses open and close square brackets, we can specify a list of functions that you would like to get evaluated using the price column. And I'm going to use np.sum, np.mean, np.standard deviation, and when you run this, you get all these values for the price column. Now you're probably wondering what happens if we want to get the same multiple functions applied to more than one column in a data frame, and that's possible. So what you want to do is just simply type g.agg and open parentheses, open square brackets, and within that you want to type np.sum, np.mean, np.standard deviation, and the output you get each of the columns, numeric columns, so quantity and price has the evaluated quantities for sum, mean, and standard deviation as seen here. These are NaNs because there was only one value, so it cannot calculate standard deviation, but we do see that for the fruits orange and which has a grade A. Now moving on, let's look at a couple of ways in which we can rename the columns that we have created after aggregating the data. So there are 5 different ways, and we are going to look at each of those. So the first method, we will go ahead and use the price column again, and we'll use the same object. So AGG, and here let's say we are using np.sum, np.mean, and np.standard deviation. Those are the quantities we are calculating. What you want to do is chain the commands. So this is called chaining. So you .agg is one, and then we are going to use .rename. So we are chaining the commands. So in rename, we want to type within open close parentheses columns is equal to, columns with a S is equal to, and within curly braces you want to type sum. That's the actual name, the original name that's going to be out there. We want to change that to, let's say, capital sum with a capital S, and similarly we want to change the mean to mean with a capital M, and let's say we want to change the standard deviation to capital STD. Now when we run this, I missed the N there, sorry about that. Now as you can see, we have successfully renamed the column names by specifying them in this rename. There is another way in which we can rename the columns, which is similar to what we did here, but then here we just used one column from the data frame. How about if there were multiple columns? So the method is the same, except I want to remove this, and we'll use the entire data frame. So now when you run this, the rename is performed on the calculated quantities, those that were in the aggregate command here, for all the columns in the data frame. So for quantity and price, we have renamed sum, mean, and standard deviation. Next, there is another method in which we can use pd.NamedAgg for renaming the columns, and to do that, what we can type is df.GroupBy, and here we are going to group by on fruits this time .agg. So now we are chaining, so agg. Here what we are going to specify is min quantity, so that's the first column name that's going to be there, and the format is that you want to specify min quantity is equal to pd.NamedAgg open parenthesis, open close parenthesis, and inside that you want to type column is equal to quantity. Okay, and after that you want to type agg function, so this is what is going to get evaluated for that column. So we'll specify np.min. So what this is telling is create a new column, name it as min underscore quantity, and put in that column the minimum of the quantity column for each of those groups. So when we run this, we can see here, so let me pull up the data frame as well. So as you can see, for banana we have the minimum quantity which is 5, and therefore it's there. For mango the minimum quantity is 2, and that's what we have. Similarly for orange we have the minimum quantity 3, and that's what we get in the output. Similar to this, we could add more than one items here. So if I go ahead and put a comma, and I'm gonna go ahead and copy this and paste it here. Let's say we want to find the max as well. So I've changed this and created a new column, max underscore quantity, and for aggregate function now we need to change what we are calculating, and here we are calculating np.max. So now when we run this, we have created two new columns which have the minimum and maximum quantity. And let's say for mango the max is 11 for quantity and 12 for price, but we are here we are looking at only fruits group by, we are looking at only quantity, and therefore the max is 11 for mango, and that's what we get in the output. Now there is an easier way to use this method without typing pd.NamedAgg, and to do that what we can do is, I'm going to go ahead and copy this and paste it here. So the shortcut method is that you can go ahead and delete all of this, and you can delete all of that and just put quantity there. I'm going to go ahead and delete this, so we just have quantity. And again for agg function you don't need to specify that, so even if you specify just np.min and np.max like here, it will still work. So as you can see, we get the same output that we had before using this method. So that was the fourth method in which you can rename a calculated column after aggregation. Finally, there is another method in which we can use keyword arguments. So let's say keyword arguments, and for this I'm going to use df.GroupBy, and let's use the fruits column again, and agg. Now here you want to put star open close curly braces, and then we are going to type contents within these curly braces. So here you want to type pd.NamedAgg, and again the same format, column is equal to, let's this time we'll use price, or let's go ahead and use quantity, and the aggregated function that we are going to use here, let's use np.min again. And when we run this, argument after star must be mapping, not set. So that's correct. So what I'm missing here is we need to specify the name of the column. So this is dictionary, so I'm gonna we put that here and create another min underscore quantity, and now what we have a key value pair, and this should work. So now this is another way in which we can create a new column which is np.min in this case, and given it a name min underscore quantity. Moving on, let's look at how we can use the aggregate on a series. We have already used it on a series, but this is yet another example. So aggregate on a series, and I'm going to create a couple of more cells there. So df.GroupBy, and here let's use fruits again. And so earlier what we have done is we had specified the column we need to calculate something on within the aggregate function, but there's another way you can do that. You can specify it right after GroupBy. So here if you specify quantity, and now if you do GroupBy, so now you are chaining aggregate here. So aggregate, and within here I'm going to put min underscore price is equal to np.min, sorry, this is quantity, and similarly we are going to max underscore quantity is equal to np.max, and this, when we run this, okay, I was missing a comma there. So this is how you can calculate for, in this case, for the column quantity, we have calculated the min and max, and also renamed the columns as min quantity and max quantity. Moving on, let's look at how we can use different functions on two separate columns within a data frame simultaneously. So using different functions at the same time. So let's go ahead and create a new grouped object. G is equal to df.GroupBy, and I'm going to use fruits again. Now here we can chain aggregate to this. So g.agg, and open parenthesis, open curly braces, and within that, for each column we can specify like key value pair. So for, let's say for price, we can say get us the sum of price, and then for quantity we can create another, we can write another functions. Let's say we want to get the difference between the min and max values within each group for quantity. So to do that, we can use lambda. So lambda x, and so what we are doing is getting the min of x, and then getting the difference with max, np.max of x, and then let's go ahead and get absolute of that. Now when you run this, here what we have are two calculated columns, each of which have a different function applied to them. So the price column was calculated as sum, whereas the quantity column was calculated as a difference between min and max. So that was it for this video. In this video, I hope you learned how to use aggregate function, how to rename columns, and also how to use different types of indices, setting it to false, so that you can have the columns as columns after the GroupBy function is completed, and then how you can apply multiple functions to during aggregation to either same column or different columns at once. In next video, we'll continue this journey with GroupBy and look at transform, which is a really helpful function as well. Please like, share, and for subscribing, you can click the bell icon below on this video. I hope to see you all in the next video. Thank you.